Welcome you all. Today we will discuss about the linear optimization and what is mean by optimization. Optimization is the process of finding the best solution from set of possible solutions. Because any problem if we are taking, we had a n number of solutions. So what is the best solution among the best solution among all possible solutions? Okay. And among this one, what is linear optimization? So linear optimization linear optimization is a subset of optimization where the objective function and constraints are linear. Okay. Optimization is to find the best solution from the all possible solutions, and linear optimization is a subset of optimization where the objective function and constraints are linear. So here there are different parameters are available in optimization. So one by one we will discuss while doing the problem. So here I directly am going to the problem, that is maximizing the profit from the product manufacturing. So what here you look at the problem statement over here. The problem statement is the a factory manager who wants to determine how many units of product A and product B to produce in order to maximize your profit. However, you are constrained by a limited resources such as labor hours and raw materials. So let us take the solution if I'm taking, okay. Uh, First one is they have taken the product A and product B. Here product A we consider as a high end product, okay, high end product which give more profit, okay, and at the same time it takes more resources. And second one is the product B which is low end product, less profit, and it consumes less resources. Okay. So this is the product A and product B. And now come to the first one, the parameter in the optimization is the decision variables. So decision variables means x1 is the, let us take x1 decision variables. Okay, x1 is the number of units of product A to produce, and x2 is the number of units of product B to produce. So ultimate of this goal is the, and one more, and here what is the profit? Example, if I am generating a product A, what is the profit will be gained by the manager or owner? So let us take, we can, if I am generating the, yeah, otherwise if I am producing the product A, I will get 40 rupees per unit. At the same time, if I am producing B, then 30 rupees per unit. Okay. So product A will gain the 40 rupees and product B will gain 30 rupees per unit. Now decision variables are x1 and x2, and second most important one is the to define the objective function. Objective function. What is objective function is either the objective function is will minimize or maximize the function. Okay, minimize or maximizing the function. So here what we are targeting, we are maximizing the our profit by producing these products, product A and product B. So it can be defined by simply I am writing P equal to 40 multiplied with x1 plus 30 multiplied with x2. So now how many x1 units, that is x1, and how many units of x2 can produce and will tends to increase the maximum profit, that we have to find from this objective function. Because x1 there is a number of we can substitute any number, x2, but where we will get the maximum numbers, and this is the objective function. And next one is the constraints. Or constraints are some limitations. Okay, we can take, there are two types of constraints in optimization. Is here we can take uh, two types of optimization. What is constrained optimization and unconstrained optimizations. So what is mean by constraints optimization means there is some limitations in the optimization. So like there is a something x1 will be taken up to the only 10, or x2 will be considered up to only 50. Like this, there is a limitations. But in unconstrained optimization, there is no limitations. We can take the value of x1 and x2, any number or any real number, whatever it is. Okay. So, but here we are focused on constraint optimization, right? So here, what are the constraints? Or you can write it as a limitations also. So constraints means limited resources are available because we are producing the product A and product B. There is a some the resources are required. One is the labor hours. You can take it as a labor hours, and second one is the raw materials. Now let us take product A. A requires 2 hours per generating or for producing. Okay, for producing 1 unit. At the same time, B requires only 1 hour for producing 1 unit. And total number of hours are left with company or manager is 100. Left with manager is 100. So how we can represent in terms of mathematics? Simply, there are 2 hours are required for product A. So therefore, we can write as a 2 into x1 plus, and 1 hour required for B. So therefore, simply x2, and total number of hours are available is 100. So first constraint. And next one is the raw materials. So raw materials is, let us take total 80 bags are available. Bags are available. So each product A consumes 1 bag, okay, for producing 1 unit. 1 unit. Okay. Product B consumes same. Let us take equal resources we will be taken for the product A and product B. So product B also consumes 1 bag for producing 1 unit. So now if I am representing in terms of mathematics, that is x1, because only one bag is consumed by A, and x2 less than or equal to total number of bags are available is 80. So two constraints are available, that is we can write it here, it as a our objective function is 1, that is p equal to 40 x1 plus 30 x2, and this is second equation, and this one is a third equation. Okay, here let us we can implement these things by using, and one more, it is a non-negative constraint, sorry, non-negative constraints. In linear optimization we are considering, that is x1 must be greater than or equal to 0, x2 also must be greater than or equal to 0. These two constraints, because number of units must not be a negative, it's a positive. So it's one more condition. Now let us solve this problem by using graphical method. Let us solve the problem using graphical method. Okay. So in the graphical method, first we have to plot there are different methods are available, but this one is easy to represent. Plot the constraints. Okay, how to plot the constraints? What are the formulas? 2x1 plus x2 equal to 100. First constraint. So when I am getting maximum x1 when x2 equal to 0, your x1 become 50, right? X2 x1 equal to 100, then x1 is equal to 50. When I am getting x2 is maximum, then when x1 equal to 0, you will get x2 equal to 100. Okay. So if I am drawing this plot, so there is a, let us take x1 is 0 and x2 is 100. So let us take 100 over here, and x2 equal to 0 and x1 is 50. Let us take 50 over here. Just we are joining these two points. Again, second constraint, it is the x1 plus x2 equal to 80. So when x1 equal to 0, then x2 is 80. When x2 equal to 0, x1 equal to 80. Okay. And then 0 comma 80 means somewhere else come here. And this 80 comma 0 means somewhere else appear here. Joining these two points. Okay. Now we find this intersecting point. This point can be obtained by solving these two equations. 2x1 plus x2 equal to 100 and x1 plus x2 equal to 80. So if I am solving this one just by subtracting, you will get, this will get cancelled. X1 equal to 20. Obviously, if x1 equal to 20, if I am substituting any equation, you will get x2 equal to 60, right? So x1 equal to 20 and x2 equal to 60. So now take all the vertices. The first vertices is the 0, 50 comma 0, right? This one. Okay. And second vertices is the 0 comma 100. And third one is the 0 comma 80. And fourth one is the 80 comma 0. And fifth one is the 20 comma 60. Now we have to verify this all vertices are is in the fusible region or not, because we need to find the all possible solutions So therefore, we need to draw some certain region by checking all these this we must satisfy these two conditions. Which one? This condition and this condition for this all vertices. Let us check. Okay. So first one is I am taking like this x1 and x2, whether it satisfies two constraints or not. Simply, when I'm substituting 50 x1 and equal to 0, just x1 and x2 and substitute over here. That is 2x1 plus x2 is equal to 100. If I am substituting x1 equal to 50, then 2 into 50 plus x2 equal to 0. So it is 100 equal to 100. So it is satisfying. And second one is the x1 plus x2 equal to 80. If I am substituting x1 equal to 50, so 50 is always less than or equal to 80. So this is also satisfying. So that is, it is satisfying two conditions. Next one is a 0 comma 100. If I am substituting these two, x2 is 100 and x1 is 0, that means first condition is satisfying, but second condition getting failed because x1 is 0 and 100 equal to 80, it is 100 is greater than 80, this condition fails. It is not satisfying this condition. Third one is a 0 comma 80. 0 comma 80, if you are substituting x2 equal to 0, x1 equal to 0 and x2 equal to 80, 80 less than or equal to 100, this is satisfying, and 80 equal to 80, this is also satisfying. So 0 comma 80, its condition satisfied. Next one is a 80 comma 0. x1 is 80 means 2 into 80 is 160. 160 is greater than 100. So this constraint is not satisfying. So therefore, this is, if any one of the constraint is fails, then automatically it cannot useful. And last one is the 20 comma 60. So 20 means 40 plus 60 100, it is also satisfying, and 20 plus 60 equal to 80 equal to 20 plus 60 means that is 80 equal to 80 means this is also satisfied. So these three these three vertices will give you your output, that is satisfied feasible solutions. Okay. Now let us check which one will give the more profit among these three. Which one? First one is this one, second one, and third one. And the region, if you plot this one, simply how it will come? Simply I can draw 50 comma 0, that is x-axis is the 50. Sorry, 1 minute. Yes, 50 comma 0, x-axis is the 50, this one. And second one is which is said 0 comma 80. So this will come over here. And third one satisfied condition is 20 comma 60 in the middle. So 20 you can take here and 60 you can take here, like this somewhere else. Okay, this region will get all the feasible solutions. Okay, in this region you will get the profit. But which one all possible solutions will get from this region. But which one is the best solution? So let us substitute in our objective function, that is 40 into x1 plus 30 multiplied with x2. This is our objective function, right? When I am substituting 50 comma 0, this is 40, 50 plus 30 multiplied with 0. So this will give you 2000. And next, if I am substituting 40 x1 plus 30 x2, that is second region which is both satisfying, that is 40 multiplied with 0 and 80 multiplied with 30. So it will give you 2400, right? Second profit means. And third one is the 20 comma 60. So 40 multiplied with 20 plus 30 multiplied with 60. So this one is will give you 800 and this one will give you 1800. So total it become 20 600. So when I'm taking the values of 20 comma 60, right? When I'm taking the values of 20 comma 60, I'm getting 2600 rupees profit. So the best optimized solution is the best optimized solution for maximum profit is x1 equal to 20 and x2 equal to 60. Okay. Here you are getting the profit of 2600. That means x1, if you are producing product A 20 units and product B 60 units, you will get the maximum profits. So this is the optimized solution for this scenario based question. So here simply revise our what we have discussed. Simply first you can take the understand the problem and turn it into the mathematical equations. That is first one is a decision variables you have to take because here product A and product B, because only two variables we have taken. This is a linear optimization, and there after this one we have to take the some constraints, and uh, here we have taken two constraints, that is labor hours and raw materials. Labor hours are available up to 100 hours only, and raw materials only 80 bags are available. And labor hours, product A will take the 2 labor hours per unit and product B 1 labor hour. And raw bags, the bags will be equally shared by the means, both product A and product C will be consumes equal uh, raw bags, that is materials. And non-negative constraints, this both must be positive. Then after finding this one, we have taken the graphical method. So for this one, we have to plot the constraints, and these constraints I have taken 2x x1 x2, where we are getting the maximum and minimum. And finally, we have solved the equation. And one more, this all vertices are appear. So this vertices, we have to check whether it is the satisfying two constraints or not. This is the most important thing, but because there are several possibilities will come, but we have to check which one is satisfying both constraints. So here among the five, three are satisfying. These three we have substituted in our objective function and finally finding the solution. Okay, this is the end of the linear optimization. Thank you all. If you like the video, please click on the like button.